welcome everyone. So it's great to have everyone here, and today we're going to be talking about event-driven serverless architecture. And we're going to be basically it's a very general architecture that you can achieve in any sort of public cloud environment, whether Azure, AWS, or GCP, or even you can do something on-prem as well with this. But for this presentation, we'll be focusing on GCP and how we can actually achieve these things on GCP. And if there are any questions, you guys can definitely ask them during the presentation, and I'll try my best to respond to you guys to give you answers that would satisfy the overall requirement of the question. My name is Sumair. So I work at Royal Cyber as an enterprise cloud architect. So I've been working with different public cloud vendors, namely majorly on GCP, and a somewhat decent experience on AWS. So I have been working. I started off as a cloud developer, worked on a couple of applications, created a couple of products using GCP services. Eventually moving towards being an architect. And right now, my responsibilities lie from pre-sales to post-sales to designing architectures and somewhat, getting involved in actually creating and running out and throughput out the products that whatever the requirements have been a part of it. So so today, that's a very brief introduction about me. Let's talk about what the actual topic here is. So this word like event-driven serverless architecture. So this is actually a culmination of multiple different ways of actually designing your architecture for specific needs. Like if we talk about just the phrase event-driven, that's a separate way of designing your system. If we talk about serverless, that's a separate way of designing your system. But normally, if we combine both of them together, that's a completely separate way of actually architecting or designing your system based on your specific needs. The overall goal here is that normally what happens is if we talk about a generic way of how systems are normally designed, so you normally have a client-facing application, and then you have two major components on your main server side. That is, you have a server which actually listens to your client requests, and your server is mainly responsible to actually talk to the database. So normally, if you talk about a very generic flow, if you want to save, let's say, your name into the database, you would rather have a form where you would actually input your name, and you would have some sort of a button or any other element through which you would be able to submit that name, and that value goes to the server, and then server is basically responsible to take that information and store it into the database, and then sends out a response to the client that the form successfully got submitted, or any other successful response, or if something went wrong, then it would send out an error or any response that sort of tells you that okay, the operation failed. Okay, so this is the overall gist of designing a very generic system where the database layer would always be behind the server layer, and the database would directly talk to the server, and the server would always talk to the database, and they would always back and forth their communication. And meanwhile, server would always be in contact with the client, and would always be in direct communication with each other. This is like a generic way of designing a very basic architecture. Most of the system that you see are in this structure are monolithics. So monolithic is like a single unit of system where that has a single entry point where a client talks to a server, and the server does its work and sends out a response to the client. So if we move to another architecture, to another way of designing system, it's called a serverless way. So basically here, what we're doing is, instead of having a single server that does all the job for us, we kind of have these small miniature servers, if I would like to say. Each miniature server, or we could call them cloud functions, or any other, in GCP they're called cloud functions, in Azure they're called Azure functions, in AWS they're called lambdas. So basically what they do is they are specific generic purpose functions where they perform a specific task that the user wants to get out of our system. So let's say if you take the same example, if I want to maybe store my name into the database, I would again interact with the form, input my name, press a button. Now this time, instead of instead of the user talking to a single entity of a server, here my request would go to either one of these cloud functions, which is actually responsible for storing my name into the database. So instead of using the whole server to actually process my request, I'm only consuming one specific part of a of a combination of different miniature servers, where which is actually which is actually processing my the data that I sent, and then saving that information, that data into the database, and then sending out the response back to the client that your information got saved successfully and stuff. So one specific cloud function it just runs, where it takes the form value, stores it into the database, and the database then sends out and then gets the response, like as in like successfully the data got successfully stored into the database, and sends out that response back to the client that sort of like in a in a green box that the operation was successful or data was successfully stored. Or if something went wrong, it would then send out a response back to the server, back to the client, that something went wrong, as in like there was a problem while storing the database, or any specific error, like maybe you don't have the specific permission to do it or something like that. So here our single cloud function is actually doing that. Okay, so this is how we normally design an architecture system in a serverless fashion. So if we move along, now this is another way. This is specific for event driven. Now in an event driven approach, what we do is we basically focus on users engagement. So as long as a user performs a specific task, the server is sort of like not doing much. It's only like like waiting for the user to actually do something. And in this case, what we're doing is we're using a pub sub function from that GCP provides us. It's actually directly registered to our user facing app, right? And so what we do here in this case, when we're trying to store information into our database, again using the same approach by filling up a field and then pressing maybe submit or go or any other button. So when we click that, we're basically doing what we're basically we have like multiple topics here that are registered, and each specific topic is sorry not registered, it's subscribed, and each specific topic basically is responsible for sending out information to the server that okay, this topic, this X topic got triggered. Now you need to perform your operations based on this specific topic. So here the server wasn't doing anything, but only to the part when it received that specific topic from the pub sub function, and then it started processing that data. Now that data can either be stored into a database or any other external service that we're using with it. It would do its work, sends out a response back to the user, on its screen, and letting it know that okay, this thing, the operation was successful or the operation failed. So here the event driven, this part, this the part this where event driven is written. So here an event was triggered from the user, and based on that event, we had multiple topics like store the user information, delete the user information, add it or update the user information, or maybe any other operation that we can think of in a generic application. So each of these topics had specific meanings on the server. So once we tried to store that data, that name into the database, that topic of, let's say, stored name into database, let's say that's the name of the topic, that topic got triggered, and that topic went to the server, it got published on the server, and the server was like, okay, I need to store this payload that I got from the cloud pub sub function, and I need to store this name into the database or do something with that name, whatever we have designed the server to do, and then sends out a response back to the user. So this is a different approach of designing an architecture to basically entertain in a sense that to have to basically only do something when the user wants you to do, and the rest of the time just sit idle, just wait for the user to actually perform any action. So if we combine both of these techniques together, So we have something called event-driven serverless architecture. Now here things are a bit different. So as you can see, the user uh, before I talk about before I talk about that part, let me just introduce one more element that I've introduced here. That's called Firebase Hosting. So here we're assuming that our front end is actually hosted onto Firebase. We can use any other XYZ service that we want to actually host our services here, host our website here. So here, what we're doing is the user did the same thing. He tried to store the name. He wants to store the name into the database, but this time the user is not connected to a cloud function or any server, but rather directly connected to the database. The front end is actually directly connected to the database here. And what it does is it's directly adding that value, adding that specific trigger into the database. And what our cloud functions are doing is our cloud functions are subscribed to different, let's say, collections. I'm going to use the word here, collections or documents. So I'll be explaining what collections and documents are, right, when we're going to demonstrate how this is actually working. So basically what's happening here, our cloud functions are actually subscribed to the database, and they're told that, okay, if someone tries to save a name into this X document, you need to maybe, let's say, send out an email, or maybe you need to maybe send out this name to any XYZ service. Let's say you need to generate analytics on it, or you need to use this data and send out to any AI/ML toolkit that we have attached with the cloud function. So
Right.
right.
We can send out a
Uh,
notification or something of that
Yeah,
sort.
exactly. You can send out a notification or anything that comes up in your mind that you want to do with that data. So basically, when that data gets stored into the database, the cloud function would run after that data gets stored there, or the data gets updated there. So based on the subscribed cloud function, that specific. Sorry.
So do Firebase, because it's known for mobile, is
Yeah.
it necessary? Are you talking specifically for mobile apps, event-driven architecture, or is it across the board?
Yeah, it's across the board. I mean, the example that I'm going to show you, we're using a React app there, so it's a web app. So it's hosted on Firebase. It's connected to Firestore, and it has cloud functions subscribed to Firestore, and we're going to see how things are working all together. So basically, it doesn't matter. It's not just related to mobile. You can actually create web apps, and those web apps can range from, let's say, a simple one page app to a whole enterprise application. And depending on how complex you want this structure to be, depending on what your business requirements are, what your business needs are, you can expand it as much as you want. And this kind of gives you a lot of leverage since you're using serverless cloud functions onto it. And the best thing about cloud functions is that you can actually run 1000 instances of a single cloud functions at the same time. So that's like creating 1000 copies of a single function, and that can move across to, that sort of gives you horizontal parallelism. So you're doing synchronization not only on software level, but you're also performing synchronization on the hardware level as well. You're actually creating multiple copies of a single cloud function that's like running on the at the same time, depending on what sort of your business use case is. So here, like I said, our front end is actually directly connected to the database, and our cloud function is subscribed to the database. So any specific action that we perform on the database would get our cloud function triggered. And once that cloud function gets triggered, it start its job. And once the job is complete, it'll go back to sleep, or wait for, or stay awake for a while to see if there are any other instructions. There's a concept called cold start.
Question.
Or yeah.
Yeah. So basically, I understand what your concept you're bringing in, but in the sense, like for example, the database, right? You're instantiating it only with a cloud function, right?
Yeah.
So what happens to the storage in database? The storage.
Um, As in storage, as in
like with the data store per se. Okay, where is the data store going to be maintained? Are you going to keep a copy somewhere else? Because
okay,
you're kind of using spot instances in this case, right? Like what we do in DevOps, right? As I understand.
okay. So what we're doing here is that, our database is actually a physical entity here. So in this example, we're using Firestore, right? So that's a database that's connected. That's a Firebase connected to the Firebase service. So the data is actually stored in Firestore, and in this example, so we're storing the data in Firestore, and based on the subscription of the cloud function, it gets triggered. So let me just demonstrate this to you guys to actually show you how the database actually looks like. So this is a very generic database of, this is how a Firestore database actually looks like. So there are collections, and then each collection is going to have multiple documents into it. So you can create multiple collections, and each collection can have multiple documents, and each document can have any specific number of information that you want in a JSON format. So as you can see in this sample example here, so what I did was there's a collection called users, and there's a document into it, and as you can see, this id gets auto generated as soon as you create a document. This id gets generated by Firebase, by Firestore itself. And then this is the document that this is the information that I actually stored into that one single document. So as the users start interacting with this database, as that number of documents would be created, and each document would be would have its own data into it. So it's like collection document, and then a document can have multiple collections, and then that collection would have multiple documents. So that's is how normally a Firestore database is actually laid out. Now, there are multiple ways to actually design this. Like maybe you don't want your actual data to be in Firestore. Maybe you're more of a, let's say you want an RDBMS. You're looking for, no, I don't want a NoSQL solution. I want a SQL solution out of it. So in that case, what we can do is we can use Firestore for our triggers only, and then store the actual data into a SQL solution. So our SQL solution, our SQL database would be behind a cloud function, where our cloud function would actually take that data from the Firestore, from the Firestore, and then store that data into a SQL database, and then sends out a response back to the user that, okay, we were successfully able to store that data into a SQL database, or we were able to successfully process that information into a database. So you could also do that as well, right? For the sake of simplicity, we're assuming that our data right now is actually stored into a Firestore database, which sort of like has this looks like this overall structure. So this is our Firestore database. That's our app interacting directly with the Firestore database, and then these are our cloud functions that are actually subscribed to the collection, or to the collection of the document. And based on that that operation that is performed on the database, the cloud function starts doing its work. Okay. So if we go to how things are working, so this is a simple app that I created. It's called COVID Pledger. So that's the simple UI here. Okay, let me just start off by clearing out the database at first. Now what you're going to see here, before I delete this, I want to show you something. You see this small information here that says that Sumair has pledged. Okay, and let me do one thing. Let me just put it here. So actually I want to show you how real time this is, how quickly the response is generated once we do that. So you see here this portion, Sumair has pledged. Now this is actually coming from the data that gets stored in the database. So let me just, yeah, let me now drag this here. Now you'll see how responsive this is, right? As soon as I delete the collection, you see, as soon as I deleted the collection, I immediately got the response on my UI. That's the benefit of actually connecting your front end directly with your database. You don't have any server processing in the middle. So you have these responses like this. You have very quick responses on the UI. and you immediately see that, okay, all right, so if there's any change in the database, you immediately see the response on the UI. So here, I'm just going to put up my name and my email, which is already present in the field, and I'm just going to press submit here. Okay, and I got this like Sumair has pledged, but you would see that, okay, nothing happened here. And then the reason is because, once the very first collection that gets created, it doesn't get updated at first immediately. So we need to refresh it for the first time, because if the collection doesn't exist, uh, we need to, refresh the UI for the first time. So I'm going to, this time what I'm going to do is I'm going to change my email address. So let's say I'm going to use your name here, Nikhil, and let's say your any email address that comes up. Like this is like very random, right? So I'm going to press submit. Did you see this document that got created? Now this information is actually coming, this information that you see on your screen is actually coming from the database. It's actually coming from here, and it's getting that information, and then and we see this response on the UI. If I delete this document from the database, that pledged UI element also got removed. And if I try to maybe, let's say, change the name to maybe, let's say, let's make it all caps. So as I changed the value in the database, it immediately got reflected on the UI. That's how crazy this is. That's how fast and responsive this structure is, because now you're not talking to any server in the middle. You're actually directly talking to the database. So there is no middleman here. Your UI is actually directly talking to the database. Now there's a question, okay, that whenever I try to talk about this part, especially I get a lot of this is something that I get a lot of times from different architects. They go like, okay, but how are you handling this? How is your database secure here? I mean, you're directly talking to the database. That means you're exposing all the database keys and stuff. You're directly talking to it. So that's a huge vulnerability. Anybody could just right click and just inspect your code and just take out the keys and put it in their app and then immediately talk to your database. That anybody could do that. So for that, Google, what GCP gives us is uh, is a is a is a tool set called rules. So here you can actually define rules to who can actually access your database. Right now everything is public, like you're allowed to read and write. So this is like somewhat a scripting language that Google provides us, where we can actually write custom rules to showcase how we can who is allowed to actually add data to a specific collection or delete data from that specific collection. So you can like create multiple collections, and you can actually define that in the rule, that if a user is authenticated and the user has this role, then he is allowed to add data into that X collection or remove data to that into that X collection. So this is how you can actually maintain the security rail. So it doesn't even matter if someone even takes our keys and then tries to access our database. So until and unless they're not a part of our system, like as in like they're not authenticated users and they don't have X and X roles associated with the user, they won't be able to do anything. They won't be able to interact with the database at all. The rules layer would actually block them. So that's how you actually secure your database layer when your UI directly tries to talk to it. So basically these rules are sort of like filters to how you can interact with the database. So that actually acts as a firewall, you could say, or a filter for interaction. And the next component that we're going to focus here are cloud functions. So this is a cloud function that basically is subscribed to our collection here. So if you can see, if I go back to the dashboard, so there's this cloud function. It's called send emails to pledgers. All right. Here, if I can zoom in a bit. All right. So you can see here we're giving it permission that if any user, if this collection, the collection of users, has a document, okay, if a document gets written into this collection, then you need to start working. So simply is putting it here that if a document is created into this collection, this cloud function would start working. This cloud function would start doing its job. So we can actually see through logs here that there's, this thing is actually working. So you see that our last logs are at 203. Okay, that's the latest logs we have here. So what we're going to do is we're just going to simply add a random document into it, right? We're going to have an auto ID here, and we're going to just have a name field, and let's say we're just going to call it John Doe, and we're just going to save it. All right, a new document got created. Let's go back to our cloud function and see if something happened here. Okay, wait. Yeah, all right. Yeah, I just remembered I put up a check here. So there's a check. Okay, so yeah, I did that for security reasons. So there's a check, this one, sent email true. So it's actually checking for this check. If this check exists, then it's going to, start doing something. So let's, add a record from our UI. Okay, did I close it? No, I didn't. Wait. Oh yeah. Okay, I forgot. It's here. So let's use some random email. So let's say johndoe@example.com. All right. So yeah, I put the name in Nikhil, so it's got it says the name same. It gave the same name. So let's go back to the cloud function. Now you can see. So we got the latest logs here. It's 207. We got the latest logs, and it started working. And the reason that it started working was because we added a new document. All right, sorry, going back. So the reason it started working was because we added a new document into this collection here, and our cloud function was actually subscribed to this collection, and based on that subscription, it was able to, it got triggered, and it did its job. Whatever the code snippet we have in it, it started, it did its job, and once the job was complete, the function went back into sleep, and would only then be triggered if we add a document and would have this check into it, like sent email true and stuff. So this is a very general example of how this architecture would actually work, how different components are. So this is a very bare bones structure. These cloud functions could actually be very you would say can be very as complex as you want. Actually, I can actually show you guys one working example here. Wait, let me
Well,
see
when
if
you're
I.
bringing that up, I just want to know what kind of applications would benefit from an event-driven serverless architecture, right? What kind of company would benefit from this? Just coming out of a total layman perspective, if you could just explain while you're bringing up your other piece.
Yeah, sure. Well, I can actually give you a few examples of different companies that are actually working on this architecture right now. So there's a company called Cloudnosis. So this is a cloud security company, right? So what it does is actually it generates governance. It actually gives you governance over your resources, over your public cloud resources of AWS, Azure, and GCP. So it's a huge enterprise application. So this product is actually using a event-driven serverless architecture. It's totally on GCP. It's completely relying on that, and it's an enterprise level an enterprise level application focusing on cloud security. So it does all of that through this architecture. And there's also one more product called Victor.
I would like to ask a question about
Sure.
the cost effectiveness of event-driven serverless architecture.
Yeah,
Like,
that's
what
that's that's a nice
cost?
that's a very nice question. So here, let's say let me give you an example of a real world app here. Okay, so if we go to database here, and let's see if we go to the usage. So So as you can see, you see this blue line here that says free. So uh, majorly the cost that you have when you're designing a serverless architecture, sorry, an event-driven serverless architecture on GCP. Now this is I'm talking about GCP. Cost varies from vendor to vendor and the type and the architecture type that you're actually going for, and the structure that you use and the services that you're actually using. So that sort of like varies, but on a bare bone level, what you have here is you have 50,000 read requests that come into the free tier, and you have 20,000 write requests that come into the free tier. When you go above that, you start getting billed for it. Okay, so if we sort of like see the billing margin that we get here for this app, a specific app, so you can see that on an average they're charged around $3. $3. That's like that's their average charge monthly cost, and right now they're charging at they're being charged at around $8. Now, do keep in mind that this site is currently has currently 1,000 active users. So that's like 1,000 active users currently, utilizing and using the database, and then we're like, and the read counts and the write counts are being also maintained here. So if I could see that, what is the read count on the last 24 hours? So the maximum read count that this site had were around was around 37,000 read counts, and had around 256 write counts onto it, and had around 224 delete counts. So that's like the total number of interaction that the database has. So it's still under the free tier. It's still under the free tier because it's not crossing 50,000, because that's where the billings actually starts. That's where the billing code actually goes, and based on that.
Normally, I mean, if we have to just create a normal VM-based architecture, not event-driven, then what would you approximate the cost as?
Depending on the sort of VM that you're using, but definitely you would not go to a low tier VM, because low tier VM is going to choke up. So you'd be like going with a VM that has let's say around 32 gigs of RAM, and would have like an SSD onto it, and that would like normally cost you around, I guess, $80 to $90 a month on a general, like if you're going with a mid tier VM. Okay,
So
and
versus your event-driven architecture
yeah.
at $8 versus like $7.
Yeah, exactly. One gotcha here. There's one catch. You see, normally when you work on these other architectures, apart from the this event-driven one, uh, the development mindset is a bit different here. So here, you don't need to focus on the infrastructure. You directly need to focus on the business logic. But the overall runtime environment, the overall environment where the code is actually executed, is a bit different than what you would normally expect from from the normal architectures that developers work on, right? So let me like give you a basic example. When a cloud function is triggered, when that code runs, what happens is that uh, basically it's a bit strict on a few things. So it goes like, okay, while I'm running the code, you need to properly send out a response that, okay, I have completed my execution. If you're not going to do that, I'm going to I'm going to sit into an idle state, and I'm going to keep on running until either I time out or I generate an error. Okay, so we also need to take care of the fact that we need to control the read and the write counts here, because that's where the actual billing is actually being taking place. Our actual billing factor is the real is the Firestore database. There was one case study that I was reading about a startup. I'm sorry, I'm not able to recall its name. So what they did was they launched an MVP, and they had this. I think it actually went on to Kickstart, and they were actually having they started getting some funding as well. But what they did, they kind of screwed up the overall architecture while designing the architecture, they kind of screwed up how their code is actually going to interact with the Firestore database, and all of a sudden they actually got a bill of around $32,000. Yeah. So in the span of like a month, they actually went bankrupt. So there are things that we need to focus on, and that's why uh, even though you get all of these good things, there are some gotchas that you need to take care of.
That's why we need you, right? You can say it.